Y'all, give it up for Jonathan, who's going to be talking about the AI Startup Spotlight powering multi-repo refactoring and analysis.
Yes.
You do both of those things?
At the same time, they go hand in hand.
Incredible. Let's do it.
Absolutely. Thanks for having me up here. We're here to talk about technical debt remediation, right? The most exciting thing in the world. I came to this problem about 10 years ago as a member of the Netflix engineering tools staff. They famously had this freedom and responsibility culture at Netflix, which meant as a member of the central team, I could impose no constraints on what my product engineers did, and yet was responsible for making the org move forward from one language version to another, one framework version to another, closing security vulnerabilities, et cetera. I spent a ton of work or a ton of time on trying to provide context to engineers about where they were relative to the goal that we wanted them to be at, dashboards, internal developer portals, that kind of stuff, and it resulted in approximately zero action on the part of the product teams. When I go and talk to folks and say, what could I do to make you move forward? They would say, do it for me. Otherwise, I got something else to do, right? Which was really, truly honest. This is where I came to the problem of how do we craft through automation source code changes that they can pull and get them to move forward without having to do kind of all that manual work. Today, we think, AI code authorship started with completions, grew into agentic authorship stuff. A lot of these experiences are magic because the LLM is getting information out of the IDE. It's an interaction between a language model and what you see in the IDE. The IDE's knowledge of the structure of the code, not just the text of the code, really is essential to making this experience as magical as it is. And I think what we're encountering a lot right now is folks assuming that we can take that magical authorship experience that we have in the IDE and it will naturally just kind of just be extended to the 50,000 repositories I don't have open in the IDE right now. If I'm thinking about why the LLM needs information from the IDE's internal representation of code, it's because there's too much information that's below the surface of what's in the text of the code itself. Here I've got this class. This represents the entirety of the source code of this dog class here. And you see this logger statement, logger.info. There's no import statement. There's no type definition here because in this specific example, I'm inheriting this from a protected field from a base class. And so the question to you would be, what kind of logger is this? Is this a log4j logger? Is this a JUL logger? What kind of logger is it when the code actually looks very similar? The IDE knows this because it not only has the text of the code or the abstract syntax tree, it also does type solving on the methods and types and the identifiers throughout. So it's able to identify through that type attribution information that this logger is in fact coming from this package, that this is the method, these are the super interfaces, et cetera, et cetera, et cetera. So if I was building a piece of automation that needed to target specifically a logger from a particular package, lacking that information, I wouldn't be very successful, right? At Netflix, I founded a project called OpenRewrite, which is designed to parse the text to code into what we call the lossless semantic tree. So it's not an abstract syntax tree, but everything that's, all the symbol information, all the transitive dependencies. And with Moderne, we serialize that lossless semantic tree to artifacts for entire business units. We work with some of the largest businesses in the world. I think Morgan Stanley is one of our customers, has almost 5 billion lines of source code under management. And I'll show you the kind of experience I want to give them, which is they have a particular problem. Like I'm trying to move from Spring Boot 1 to 2 to 3 to 4, this kind of thing. Through a series of OpenRewrite recipes, which are deterministic programs that make these kinds of changes. the Spring Boot 3.4 recipe has accumulated 3,400 different migration steps that help you get from one thing to another. So to move to 3.4, you first have to get to 3.3, which means you have to get to 3.2, which means you have to get to 3.1, which means you have to get to 3.0, which means you have to migrate to Java 17, which means you have to get to 11, right? So each of these are the individual steps of how to get there. And what I want to do is surface to a product team, I'm a product team on this business unit. I own this set of repositories, and I'm saying, I want you to go to Java 21, or whatever the case might be, right? It doesn't really matter what it is. I want to surface to them where they're at and also provide that upgrade button, that click-through experience. The recipe has ran against that lossless semantic tree data, and it's suggested the change throughout. All the change that's necessary to get me to where I need to be. As a developer, I'm looking at this, I could say, why did this change? Well, I'm trying to get you to use this new idiom because this is a new paradigm that exists in the language I'm trying to get you to, which you may not even know about yet, because I'm also so you're trying to provide narrow and broad context to the developer about where they're at relative to this. And then ultimately, the experience I want to give is to say, as a developer, commit directly not to just one repository that I have open in the IDE, but all 162. Or create pull requests or draft pull requests or whatever the workflow is for me in particular. It's dealing with my business unit as a whole, not just one in particular. When I started this company and when I was working on this problem at Netflix, I was very focused on the transformations themselves. What I didn't realize yet at the time was the application to impact analysis as well. It's, in many cases, studying the problem precedes building the transformation that actually affects it in the end. So one of the asks from Allstate years ago was really, I want to itemize every REST endpoint that I have in my organization that produces a particular piece of PII. And this is a toy form of this recipe, but to say, go through all of my code, try to identify every REST endpoint that directly or transitively produces a last name field. And if I look at the text of this code, I see this, this particular REST endpoint that returns a veterinarians object. And, veterinarians itself has a vet list, which returns a person, which has a last name on it. I could give this same text of this code to a large language model. It has no idea what's inside that vets object, right? So the kind of relationship to language models now is that all of these recipes that we have in this marketplace, is thousands and thousands of recipes that have been developed by framework authors, by hyperscalers, by end users for a variety of different technologies, can all be exposed to a model as tools in the tool function paradigm. In that, really all of these recipes have descriptive text on them and options that can be used in different combinatorial ways, so that I can ultimately have a chat forward experience for my large scale impact analysis or transformation. If here I just say, what versions of Gradle am I using? The model can go locate, is there a recipe or set of recipes that would accomplish this thing I'm trying to ask on potentially tens of thousands of repositories worth of this lossless semantic tree data that I've pre-serialized. And so it finds this fine Gradle wrapper recipe. It realizes that that recipe produces a data table, which is columnar information according to a schema the recipe is choosing. It executes it. That recipe is producing this kind of raw data. The model is able to write a query, a SQL query against that recipe, and ultimately produce that kind of ad hoc visualization and impact analysis of what's going on in that organization. If that looks pretty magical, it's actually in many ways very similar to why our agentic authorship experiences are magical, because it's really bolting to a similar density of information about the code that's in the IDE right now. As a market in general, I think so much money has flowed into authorship tools simply because there was an easy technical integration with that rich representation of code that was in the IDE. I'd like to show you a couple other quick examples of just so you to kind of broaden just ideate on what's kind of possible with this. One of the common questions is trying to do this kind of dependency management type studies, but not just on one repository at a time. Try to understand it holistically across a business unit. So Jackson in the Java ecosystem is often a problem. That a lot of remote code execution vulnerabilities and so forth. I'm just trying to figure out how this freaking dependency is coming into my org, and that actually may not be visible from the text of the code itself. So for example, right here in this XML of this dependency declaration, this Cloud Foundry client transitively drags in Jackson Data Bind 2.13.1. And it's interesting to see that particular occurrence. Who could say right now on these 200 repositories, what is the predominant version of different Jackson artifacts that are getting dragged into this business unit? And like, do I have a lot of self-similarity in version, or do I have a lot of version dispersion? So recipes can be designed to emit data tables. Data tables are these rows and columns of information, and that can be aggregated across many repositories and exported in various ways. So I'll show you the raw data table here that we're downloading here for the dependencies in use. And it'll contain kind of just this like itemization of every single way in which Jackson came in to the code base. So you can see this repository, this project, and this source set brought in this particular artifact at this version. And dep2 means it was a transitive dependency, not visible in the text of the code if I just look at that. Really what we saw the model doing is just building a visualization that's injected with that data, that dynamically for a business unit, and then reasoning about it in some way. So I'll show you a similar form here, which is just going to render a histogram per artifact of the version dispersion of this particular dependency or set of dependencies in the org. I've got versions ranging all the way from 2.3.3 up to 2.19, and you can kind of see this pretty strong concentration band around the 2.17 version right there. That's the kind of thing that I'm really after. One more quick example of just finding things that are just not visible in the text of the code. I used to work for the Spring team, an open source framework that's fairly popular in the JVM ecosystem. If I select the Spring organization itself, not to pick on my old team here, but they have about 160 repositories under management. And if I just look for deprecations of their own code in their code, what am I going to find? So they're constantly making changes. All of us enterprise developers are trying to keep up with all these changes. And the hilarious thing is they have trouble keeping up with their own deprecations. They don't actually know that, this particular register bean definitions has been deprecated at that point. This is not visible in just the text of the code, right? It's just a method invocation. What about register bean definitions tells me it's deprecated? This is information ultimately that the compiler sees when it's compiling this code. And if I open this file in the IDE, you would see that yellow squiggly line underneath it that says, "Hey, you got something to do." So this is my passion and my interest is essentially opening every file in the IDE all at once and then acting on them. If this is of any interest to you, would love to talk to you afterwards. And thank you for your attention.